Have you ever wanted to know the answer to the age-old question of whether or not ice cream is better in a cup or a cone? While the answer may be based on preference, advanced tree diagrams can be used to figure out the probabilities of certain outcomes from set groups. Let's hear from some Osceola students their opinions on this matter.
Who am I here with today?
Connor,
And what is your grade level?
12.
I gotta ask you a really important question. Do you like your ice cream in a cone or a cup?
I'd say cone.
Why do you say that?
I like taking my time, savor the flavor.
Thank you, sir.
Yep.
Okay, what's your grade level?
12.
Cup or cone?
Cup. Thank you.
Okay, what's your grade level?
12.
Cup or cone?
Cone, please.
Open it.
Open it.
Are you trying to see if I open it upside down or
Now, what's your grade level?
12?
Cup or cone?
Cone. Thanks.
Hello, my name is Aiden, and today we're going to be going over the advanced tree diagram. So we're going to start with our question. A survey was conducted at a high school with the goal of finding whether students and staff prefer a cup or a cone when having ice cream. Out of 100 participants, 20 were staff, 40 were upperclassmen, 40 were underclassmen, and the results show that 40% of staff chose cup, 80% of upperclassmen chose cone, and 30% of lowerclassmen chose cup. First, we will start by setting up our diagram, and in order to do so, we need to make the diagram with 3 branches for each group: staff, upperclassmen, lowerclassmen, and then 2 branches for the 2 choices of the survey, being cup and cone for each one. For step 2, we are going to want to fill in the probabilities given in the problem. So for example, if 20 out of 100 participants were staff, that would be 20% or 0.2, and you would also do the same for their choice of cup or cone. So for example, if 40% of staff chose cup, you would use the complement 0.6 for the probability that staff would choose cone. After filling out the probabilities, you want to multiply the values of each branch to find the probabilities of the outcomes of the survey. So for example, if you had 0.2 for staff, you'd multiply 0.4 for cup to get a final probability of 0.08. And you also want to make sure that all of these probabilities add up to 1. So now that we have our completed diagram, we can move on to question A. What is the probability that we randomly pick a lowerclassman given that they chose cone? So to solve this problem, we need to divide the probability that a lowerclassman chose cone by the probability that any of the participants chose cone. So you would take the probability of lowerclassmen choosing cone, which is 0.28, and you would divide that by the probability of anybody choosing cone. Add all of those up, and you have your final answer. Now for question B, we want to figure out the probability of someone randomly being picked that chose cup, or the probability that they are staff. Remember, or means add. Now, to solve this problem, you need to add the probabilities that someone chose cup and the probability that someone is staff. Then subtract the probability that a staff member chose cup because you don't want the data to overlap. After that, you would simplify it all out, getting you a final answer of 0.4. Lastly, question C, we would like to figure out the probability of randomly picking an upperclassman and someone that chose cone. And this one is fairly simple. It's already worked out and filled out in a diagram. You just simply have to follow the branches that lead to the outcome of the upperclassman choosing cone. Would be 0.32. And that's it.